Okay, so I thought I'd talk to you about machine learning and basically what I've been up to since I've been here. So a quick introduction. What is machine learning? It's a subfield of artificial intelligence where it provides the ability to automatically learn from experience or data, but without being explicitly programmed to. So the algorithm doesn't know anything about the domain problem. All it sees is a bunch of numbers, basically, and it gives you an answer. Two main branches would be supervised and unsupervised. So supervised would be, let's say you wanted your algorithm to learn whether if you give it an image of a cat and a dog, whether it's a cat or a dog, you'd give it a bunch of images of dogs and cats and label them as dogs and cats, and then it would learn from that. Or unsupervised, where you just give it a bunch of images and it would try to find something in common with the images. So, okay. So in respect to financial decision making, there are actually some issues with using machine learning. So one of the main ones is a lot of the algorithms, for example, neural network, they're effectively like a black box. The answers they give you, you've pretty much no idea why they make that decision. So this can pose problems for businesses because you have to kind of justify why we are advising somebody to do a certain thing. And as an illustration, there's tanks at the bottom, not for it. They are there for a reason. So the US Army tried to develop an algorithm that would detect Allied tanks, US tanks or Russian tanks. And so they fed a bunch of images of Russian and American tanks into the algorithm. It kind of worked okay, but for some reason on a lot of the images it just didn't work at all. And what they found was they'd given it a bunch of images of US tanks where the sky was blue, and the Russian tanks had dreary weather in the background, so the algorithm wasn't actually looking at the tank at all, it was just looking at the sky and saying, well, if it's sunny, it's US, right, because they're in a desert, and if it's, overcast, it's Russia, obviously. So, so there are definite problems with just blindly applying machine learning. So what is a typical machine learning pipeline, specifically for DB advice? You find an expert. Great. You extract some experience from it. You find your methodology you want to use. You grind them up there and outputs the model. And so the methodology and model I'm using is a decision tree. So this is what the kind of result looks like. Part of it. I couldn't fit the whole thing on there. So it is what it sounds like. It is just the output is a decision tree, and the reason why I chose this algorithm to use to answer the DB transfer question is because the output is very intuitive. It is effectively what is in the solution mapping of current existing products. It's just a bunch of if statements based on the information you have about the person. It is explainable to anybody, basically, I would say, and it also gives good insights on what are the most important inputs to the model. What is the most important thing that you use to make the decision whether to transfer or not. So this has actually had we've been able to look at the preference questions, for example, in the fact find, and say, well, this preference question doesn't have any influence, basically. It's on whether you transfer or not, according to the data. So what kind of progress have we been making? I've been able to get about 73 to 75% accuracy on the DB cases I've seen from Greg. So he's given me his cases and I've been able to replicate only about 73 to 75% accuracy. And we've gained some, like I said, gained some insights on the importance of the preference questions. And so this plot here is just an illustration of, as you include more data in your training set, the accuracy doesn't increase, but it is tapering off, it's leveling out, and that's indicative that we have potentially noisy data. So we almost, no matter how much data you give it, it's quite possible we'll never get above that percentage. So there's some limitations here. Maybe with a bit more clean data we would be able to do that. So another possible approach using decision trees is what I'm going to call a hybrid approach. So this is actually a recreation of the solution mapping for Retirement Wizard based on their test data. So they've just got a bunch of test data there, test their own solution mapping, and I've just sent this through the decision tree algorithm, and it's come out with something that is kind of reasonable. And what we can do with this, you might think like, what is the point of just recreating a already existing solution mapping? But you could create this this decision tree, and then as you get feedback from the client or the tenant, you can feed that feedback back into the model, and the model itself will just automatically update. So you don't need to mess around with changing weights and all this sort of stuff in the solution mapping. Programs don't have to do that. They can focus on better things, and so that could be one approach in the future that we look at. So what's next? Going to try some exciting stuff with anomaly detection. So this would be detecting like cases that the current system would likely struggle with, so we can just flag them before it goes through. I could look at multiple model approaches, so basically just look at more than just decision trees and sort of pull the answers together to get a more stable answer. And then most importantly, I think we need to acquire more clean data. So thanks. Any questions? Or? Yeah, sure.
So you're saying you've got a model that does DB transfers to 70% accuracy already?
Yeah. Funnily enough, that I almost had that in the first couple of weeks. It's just I've not. I got it at about 70 in the first weeks, and then the preceding time after it's only increased about a few percent or so. So yeah, I'm reaching kind of a wall with that.
So that sounds really good. So can we test that somehow? Can we try it out? Can we get it live? What's the plan? If that's
the plan is to run it alongside the kind of deterministic solution mapping that Pete's doing, because as Joe said, that will train the model to tend towards what we're doing, and we can look for discrepancies between the two and ask questions about which do we want to go with. Do we think that machine learning has got the right answer, or do we think that the kind of curated advice has got the right answer? Where do we kind of stick this anomaly? So we probably will in DB Transfer Wizard end up firstly with a hybrid model.
And something I didn't really get into that much, if you actually looked at that tree closely, the decision tree for the DB transfer, there are some glaring kind of like issues where you're like, well, that's a dumb decision for deciding whether somebody should transfer out. So there are some wrinkles still in the system. More data generally will help with that. But yeah, cool.